All right, today we're going to go through a little 10.7b, which is going to be properties of logarithms. So we're going to, first thing we're going to do is go through a couple of little quirky formulas that you'll see, or little things that will help you simplify before we get into a couple of the bigger properties that we'll have. I'm going to talk about the one over here on the right first. So if you have log base something to the same something raised to an exponent, that thing is going to end up equaling the exponent. For that to be true, these two things have to be equal, and I'm going to prove that in a second. And then as well, if we kind of reverse that around, if we have something exponential raised to an exponent that has a logarithm, that the base of that logarithm is the same as the base of your exponential, with this w as an argument, it will end up equaling w as well. So let's see why. Let's go through this first one over here on the right first. Okay, let's say I didn't know what it was equal to. So log base b of b to the w equals I don't know. If I take that thing and switch it into exponential form, I would have b to the question mark equals my argument here, which would be b to the w. Well, for that thing to be true, that question mark would have to equal w. So if the question mark equals w, then that would mean log base b of b to the w equal w. Okay, now for this to be true again, this and this have to be the same. If they're not the same, then the property doesn't work. So for instance, let's say I had log base 2 of 2 cubed, that's going to end up equaling 3. Okay, and again, the reason is, let's say you didn't know that. So log base 2 to the third is 8. 2 to what power gives you 8? It's 3. So again, that's why that works. Now, these two things were the same. That's why it was equal to that. If they aren't the same, so if you have log base 2 of 3 to the fifth, that does not equal 5 because these two things are not the same. Okay? So there's that one. Then the other one. So b, oops, that's a terrible b. B raised to the log base b of w. Okay, again, let's say we don't know what that equals, right? So since this is an exponential form, I'm going to switch this now into logarithmic form. Just divide it there so we don't see that. So if I switch this into logarithmic form, log base b of the question mark equals log base b of w. So again, for these two things to be true, question mark has to equal w. So again now, b to the log base b of w is equal to w. So just throwing some numbers in there, if you had 5 to the log base 5 of 32, that would equal 32. Okay, again, those two things have to be the same. All right, let's go through some simplifying of these here. 7 to the log base 7 of 6. All right, so property we just got done talking about, base and base are the same, so therefore that will equal 6. This would go along with the second one, log base 3 of 3 to the x minus 5. Bases are the same, therefore that would equal the exponent, which would be x plus 5. From this point forward, when you see these things, you don't have to show why it is. All right, it's a property that we've learned. You can just go ahead and write down, in this case, x plus 5, or in this case, 6. If you want to show some work with it, it's fine, but you're not required to do that. All right, what is the inverse operation of adding 5? So inverse, remember, means to undo. So if you add 5, that means the inverse operation of that would be to subtract 5. All right, is the expression meaningful when w is equal to -3? So according to this property here, this is from before. This is just supposed to equal w. The problem is log base 2 of -3 isn't defined. And again, let's ignore the fact that it's 2 to the power of. This is just the exponent part. If I would set this equal to something, I'm going to call it x. 2 to the x is equal to -3. 2 to no power is ever going to give you -3. Whether it's a positive number, negative number, 0, irrational number, none of those will give you -3 for a solution on that. So, like we talked about a couple of sections ago, this has to be greater than 0. So plugging in -3 doesn't work. So even though this follows along with a property, it doesn't follow the original domain of this piece, which has to be greater. The argument has to be greater than 0. So therefore, this one doesn't work. But this one's okay. And when you have log base 2 of 2 to the -3rd, 2 to the -3rd is just 1/8. And so you can do a logarithm of a fraction. That's okay. So that one does work. So this one's good, that one's not. All right. So for x, if you have this, all right, so let's use our properties. 4 to the log base 4 of x, that will just equal x. And log base 7 of 7 to the 5th will equal 5. Therefore, x is equal to 5. Nice and simple. Sometimes the problems are just that easy. All right, let's do a little bit of manipulating around here with this one. So if I have 6 to the 5 times log base 6 of 2, well, from what we did like on this last problem here, where 4 to the log base 4 of x was just x, there was nothing here. I was just able to match that up. But now this 5 kind of throws things off. So let's manipulate this around. Remember that x to the, I don't know, let's say x to the 6th is the same thing as x to the 2 times 3, which is the same thing as x squared to the 3rd, which is the same thing as x to the 3rd squared. Okay, all of those would be the same thing. I'm going to do the same idea here. So I'm going to take this 6 when I have 5 times log base 6 of 2. I'm going to flip-flop that around, and I'm just going to do 6 to the log base 6 of 2 to the 5th. Okay, same thing that I just did over here. When it was 2 times 3, I did x squared to the 3rd or x to the 3rd squared. Same idea here. When these two things are multiplied together, I am going to separate it and have one of them go along with the 6 and the other one be on the outside of the parentheses. I would say it doesn't matter which one is which, but you don't want to do 6 to the 5th. I want to do 6 to the log base 6 of 2, because that's just simply 2. That'd be 2 to the 5th, which is 32. All right, moving along. So we just basically talked about these two things on the previous page. When you have, if x is equal to y, these two things will be true, and the opposite would be true. If you have these two things, then x will equal y. Think about this logically. If you have 2 to the x is equal to 2 to the 5th, doesn't x have to be 5 for that to be true? And if I have log of x is equal to log of 5, doesn't x still have to be 5? Or vice versa, if I tell you that y is equal to 3, then 7 to the y would equal 7 to the 3rd, or 8 to the y would equal 8 to the 3rd, or 30 to the y would equal 30 to the 3rd. Okay, those would all still be true. And then the same thing with the logarithm. If y was equal to 3, then log base 8 of y would equal log base 8 of 3, because still y would still have to be 3. Or 18 for the bases, or 118 for the bases. As long as those two things are the same, these two things would have to match up as well in order for the problem to be equal. Okay, now, we are not, if I give you 7 to the y is equal to 7 to the 3rd, I am not, quote unquote, canceling 7s. That's not what's happening. I'm just saying if these two things are equal, the exponents would have to be equal, or vice versa. If I give you equal exponents, then these two exponential expressions would be equal as well. Okay. All right, let's do a little solving. Log base 2 of x plus 5 is equal to 8. All right, so the object, as with any solving equation, is to solve for the variable it's given, x in this case. So with logarithmic equations, what you're going to want to do typically is to get the logarithm by itself. So that would mean taking and moving the 5 to the other side. So I subtracted 5 to both sides, get log base 2 of x is equal to 3. What do you do from here? You can sit there and try to figure out what the number is. Log base 2 of what gives you 3? It turns out to be 8. Or you can take this thing and switch it into exponential form. So 2 to the third is equal to x. 2 to the third is equal to 8, so x would end up being 8. Okay. You should technically take a look at this, plug this back in, make sure that works. Well, log base 2 of 8 is 3, 3 plus 5 is 8, that one works. So good with that. All right, next one. What if I have an exponential and I want to take this thing and just solve it for y? So I want to get y by itself. Now, there's another variable in here, so that means when I'm finished, there's going to be a variable over on the right-hand side. I just want the y to be by itself. So let's do this logically here. 1 would need to move, the 2 would need to move, and somehow the 3 would need to move to get the y by itself. So first thing I would do is add 1, then I would divide by 2. Here you get kind of stuck. What would be the process for getting this y out of the exponent? Well, I am going to switch it into logarithmic form. So logarithmic form would be log base 3 of this whole thing as my argument is equal to the exponent. Oh, hey, how about that? The y is by itself, and I am done with the problem. Okay. So the moral of the story on both of these problems here is when you get to a certain point, if you are in either logarithmic or exponential form and you don't know what to do, you get stuck, switch it into the other form and see if that helps. So when I got to here, sort of got stuck, although you can, kind of figure out what this number is, but you technically get stuck. What if this was 5 and this was 1,000,002? You switch it into exponential form to be able to solve that. And the same thing with this one here. When I had exponential form and I get stuck here, it's not the only way to do this, but one of the ways to do this would then be to switch it into logarithmic form. And in this case, it just gives you what you're looking for. All right, let's do one more. All right, so I have this. I'm going to use one of the properties. Now, if this were 2 to the x plus 1 is equal to 4, I could make that into 2 squared, but because 5 isn't, 2 to a power that's a nice pretty number, it's an irrational number, I'm going to do this instead. I'm going to do a logarithm. So, because I use the same base on both sides, this would still have to equal this like it was originally. So me putting a logarithm here doesn't change the fact that this has to equal this, as long as the two bases are the same. I chose base 2 because on the left-hand side, log base 2 of 2 to the x plus 1 will just be x plus 1. If I would have picked a different base, I wouldn't be able to use that trick. Now, there is another rule that you'll learn in pre-calc next year that you could do something besides log base 2, but for our purposes, it's just easier to make these two things here match. Don't make these two things here match, because what are you going to do with that exponent? You could do log base 5 of 5 and be able to simplify that into 1, but that doesn't help you. This is the one that helps you here. All right, so then you have this, and then again, we're just trying to solve for x. You would take that and subtract the 1 over to the other side. Now, if I asked for an exact answer, this is the exact answer. If I asked for a decimal approximation, then you could take that thing and plug it into your calculator, read the directions on what it says. Typically, I would probably say we're going to leave this as as an exact value. All right, so that is 10.7b. Let me know if you have any questions.